Hello, this is the Solidworks design of a Kant twist clamp, designed and presented by Miles Fife, Brian Harris, and Garrett Brown. This is from the course DFT 170, Engineering Graphics, from semester Fall 2024. Instructor is Dr. Hans Chapman. These are our reference images that we used to design our product. These are the sketches we used to brainstorm and design our product. This one has the smaller bracket and the spacer, and the other one has the sketch of the rubber grips. This is the sketch of the threaded spacer, and in the other sketch it has the larger bracket and the threaded pole.
The pole holding spacer was made by sketching the base of its main body. This was done by using a line and an arc. This shape was then extruded. A circle was sketched onto the front face of the shape, then mirrored to the back face using a center line. Both circles were then extruded. The threaded spacer was created by sketching a rectangular shape, then using the Revolve Boss base tool. The hole was created by sketching a circle on its round surface before using the extruded cut tool. The spacer was made by sketching a rectangular shape, then using the Revolve Boss base tool to create the full part. The rubber gripper was made by sketching a square, then extruding it to create a cube. A circle was then sketched onto the front of the cube. We then used the extruded cut tool to cut a circular hole through the part. The large bracket was created by sketching its shape, then using the Extrude Boss base tool. Certain corners were then rounded off using the fillet tool. Two circles were sketched onto the part. One would be used in two linear patterns, and the other would be outside of that pattern. The extruded cut tool was then used to create each hole. The small bracket follows a similar modeling process. The threaded pole was made in a similar way to how the spacer was made, since we utilized the Boss base tool in a similar fashion. A circle was then sketched onto the front and cut into a hole. The fillet tool was used to round off corners. The handle was created by sketching a rectangle, then using the Revolve Boss base tool. The edges were rounded off by using the fillet tool.
This is our assembly view of the twist clamp. And this is our drawing document. We have the front view, top, side, and isometric view. We chose this as our front view because it had the most circles in view, and it also showed the most detail. This is a video of our exploded view. This is our simulation. We set the material to stainless steel and put 500 newtons of force on the two hands of the clamp. It held up mostly well. There's a little bit of bending on the smaller arm, but overall it held up decent. This is the animation of the Kant twist clamp opening and closing.
During this project, we used technical skills such as sketch, extrude, revolve, mirror, chamfer, fillet, and extruded cut that we learned during the course to create a high-quality product. We also used drawing documents, assemblies, simulation, and animation to design and present the part with clarity. We also used hand sketching and brainstorming to create dimensions and create primitive design for the finished product. We also use engineering problem solving and engineering design process to design and model the part with efficiency. We also learned soft skills such as teamwork, communication, time management, and problem solving. Thank you for listening.